Select the products formed by the reaction step shown below. So what we have here is part of a reaction mechanism. And so in a reaction mechanism, these curved arrows always indicate the flow of electrons. And the fact that you have a normal arrow with 2 barbs tells you that you're moving 2 electrons. That will be the case for most of organic chemistry. So before we do this, I'm going to fill in the lone pairs of electrons on the chlorine. And then we're going to follow through these arrows. So what this first arrow tells us is that this lone pair of electrons that was on the nitrogen is moving towards this carbon atom. So this indicates that we are forming a new bond between this nitrogen and this carbon atom. So let's start drawing that structure. So we had 1, 2, 3, 4 carbon atoms. We still have 1, 2, 3, 4 carbon atoms. And we're saying that this carbon now has a bond to the nitrogen. It's those 2 electrons in the bond. So I'm going to draw it in pink so we can see that. Okay. And then this nitrogen still has 2 bonds to hydrogen. So we will place those on there. And the bond to the CH3 group. Okay, and so when these electrons came in to form a bond, that carbon atom originally had 4 bonds already. It had the bond to carbon, a bond to chlorine, and 2 bonds to hydrogen. Carbon cannot have more than 4 bonds. So when this nitrogen moves in to form a new bond, the bond between the carbon and the chlorine breaks. And that's what's indicated right here. So we're going to take the 2 electrons from that carbon-chlorine bond and place them just on the chlorine. So we are going to have this chlorine. It had 3 lone pairs of electrons, and now it has 1 more. And we also need to track the formal charges here. So the formal charge on this nitrogen would be +1, right? So we get that formal charge on the nitrogen with a little bit of easy math. So you're going to take your valence number of electrons, and then you're going to subtract from that the electrons that are on the structure. So if that nitrogen had any lone electrons, we would count those as belonging to nitrogen. And then with covalent bonds, those are shared. So we would count 1 electron from each of those covalent bonds. And there's 1, 2, 3, 4. So 5 minus 4 is +1. And then if we take a look at the chlorine, this has a -1 charge. And we can do this calculation pretty quickly as well. So the formal charge on the chlorine, so 7 is the valence number from the periodic table. And then all 8 of these electrons belong to chlorine. There's no bonds, they're not shared. So 7 minus 8 is -1. Right? And we should also notice that that gives us, so this is option A, and that gives you an overall charge of 0. For your entire system. And what you started with, the amine was neutral, the alkyl chloride was neutral, so this also had an overall charge of 0. So that's a good way to check to make sure that you haven't accidentally lost or gained electrons in your system. So your overall charge should be constant from going from your reactants to your products.